Hi everyone, we're going to be taking a look at the tide example, which is on page 44. It is challenge number, I'm going to call it challenge number 9, and I'm going to walk you through it. So the problem goes, the time between high and low tide is 12 hours. The high tide of 25 feet occurred at 3 a.m. The low tide was 15 feet. Write a cosine equation to represent this information if midnight is equal to time 0. Sketch a picture to support your work. Okay, so let's start by drawing in a grid for our graph, and we're going to take a look at the period first so that we have an idea of how big or how long our x-axis should be and what it should go up to. So it says that the time between high and low tide is 12 hours. Now you know one period would either go from high tide to high tide or low tide to low tide. So they're giving us a 12-hour period for high to low tide. So to go from high to high then would be twice as long, and so our period then is 24 hours. Okay, and I hope that you had an opportunity to check out the little video that I put into Google Classroom on the 24-hour clock, because that's what we're going to be using on these examples. And all of these equations that you come up with use the 24-hour clock. Okay, so let's start by graphing. So putting in our x and y axis. So our y axis is going to be for the height. We know that our maximum tide height is 25 feet, so we're going to start at 0, go up by 5s, and go as high as 25. And then for the x-axis, we will do a full 24 hours, and then because our high tide starts at 3 a.m., we want to go 24 hours from that. So that's going to take us from 3 a.m. to 3 a.m. So I'm going to start by putting in 24 hours and then dividing up my x-axis. So half of that is 12. We're going to go up by increments of 3. So half of 12 is 6, and then between 0 and 6 is 3. Between 6 and 12 is 9. Halfway between 12 and 24 is 18. Halfway between 12 and 18 is 15. And halfway between 18 and 24 is 21. And then we're going to add one more increment of 3 to get our full 24 hours. Okay. So I'm going to start by drawing in some guidelines. We know that our maximum height is 25 feet, so I'm going to put one there. We know that our low tide is 15 feet, so I'm going to put one there. And I know that from the diagram you can tell what your vertical displacement and your amplitude are almost right away, but we're still going to calculate them because you're responsible to know how to do that. So our vertical displacement is going to be our maximum height plus our minimum height divided by 2, and that gives you 20. So at 20 we can put in another guideline. And then our amplitude, we're going to use our y max equation. Okay, y is equal to the vertical displacement plus the absolute value of the amplitude. So in place of y, you put 25. In place of d, you're going to put 20, and you're going to solve for a, and you get 5. So we have a amplitude of 5. Okay, so let's graph. We know that we have a high tide at 3 a.m., so we're going to put a point there. We know we have a low tide 12 hours later, so 3 plus 12 is 15. So at 1500 hours, we're going to put a low point. And then we know another 12 hours from there is our high tide, so that's at 3 o'clock in the morning again. Okay? And then other points would be between our high and our low tide, so halfway between 3 and 15 is 9. Okay, and halfway between 1500 hours and 3 a.m. is going to be 21. So we put a point there, and then we can graph in one full cycle. Okay, so what other piece of information do we need? We need to know a value for C, okay? And what we'll do is we will start at our 3 a.m. So our C value then is going to be 3. Now keep in mind your C value can change, okay, as we move across the graph. I can get a sine graph from this graph. I can get another cosine graph. So we're going to write a couple of equations and just to illustrate that, okay? All right, so our format then is going to be H equals A times cos of 2 pi times T minus C over our period plus our vertical displacement. Okay, so keeping in mind that our amplitude is 5, we can plug that in for A. And we're going to start at 3 o'clock with our high tide, so our C value is 3, so we're going to go minus 3 over our period, which is 24, plus D. Okay, so that gives us an equation for this graph. Okay, well, let's say we want to come up with a sine graph. Okay, well, that means we have to start here. Okay, and I'll go like that. So let's write a sine graph for this. If we write a sine graph, then our C value is going to be 9. So our new equation will be the height is equal to, and notice that our sine graph is showing a vertical reflection, so we want to put in -5, and then sine, and then 2 pi, and T minus 9 this time, right? Over our period, which is 24, plus 10. Okay, so let's say we want to draw or give another equation for another cosine graph. We could start here. Okay. And our C value then would be 15. Okay. And notice we have a vertical reflection with that. So we will get H equals -5 cosine 2 pi T minus 15 this time over 24 plus 10. Okay, so hopefully you understand that, and we're going to do one example to kind of review that before we move on to other work. So on the next page, we'll take a look at 363. Okay, you're asked to write an equation. It says for all tidal questions make time equals 0 equal to midnight. Our question is the time between high and low tide is 10 hours. The high tide of 60 feet occurred at 3 a.m. The low tide was 30 feet. Write a sine and cosine wave to represent the data. Okay, so let's consider our period. We can see that from high to low is 10 hours, so then from high to low to high would be twice that. And so our period, twice 10. So our period would be 20. Okay, and let's start graphing then. So our y-axis once again is still the height, this time in feet. Our x-axis is still time and in hours. We're going to do a full 24 hours, so from 0 to 24, split up our graph into increments of 3. Okay, we have a high tide of 60, so our y-axis will go up by 10, so 10, 20, 30, 40, 50, 60. And we will draw in some guidelines. Okay, so our high tide is 60. Our low tide is 30, so 10, 20, 30. Okay, to calculate our D, we take our high tide plus our low tide divided by 2 and that gives us 45. So at 45, we can draw in our midline. Okay, our A value, y equals d plus the absolute value of A, so 60 equals 45 plus A then equals 15, and so we have an amplitude of 15. Okay, so let's graph this. We have a high tide at 3 a.m. We have a low tide 10 hours later, so 3 plus 10 brings us to 1300 hours, which is approximately here. And then we're back up at high tide again, another 10 hours later, so at 2300 hours, which is approximately here. And so we have one full curve, one full period of our cosine. Now, our midline points, okay, are 5 hours between a high and a low. Okay, so if we have a high tide at 3, then 5 hours later would give us a point at 8. Okay, and if we have a low tide at 1300 hours, then 5 hours later would be at 1800 hours. Okay. All right, so we're going to start with our cosine equation first, because that's the graph that we can see right away, which is obvious to us, this one. All right, and we know that our amplitude is 15, so we're going to go 15. There's no vertical reflection on that graph. And then we will write in 2 pi t minus our c value, which, because our high tide is at 3, we're going to go with a c value of 3. Divide it by our period, which we calculated to be 20, plus our vertical displacement, which is 45. Okay, so let's write a sine equation. We're going to start with a c value at 8, and just remember the way we get that is we want to take our high tide and add 5 hours to that, okay, to give us 8. And so our equation then, our graph looks like this, right? All right, so notice we have a vertical reflection, so we're going to have a negative a value, so negative 15, and then 2 pi t minus 8 over our period, which is 20, plus 45. Okay? All right, so that concludes 363. And then from here, we're going to move on to page 47. And we're going to take a look at a graph that has already been done for us. Okay, so 371 is the graph we'll be looking at. Okay, so we have a graph. We are given a possible equation. Okay, it is the height is equal to 6 cosine of 2 pi times t minus 2 all over 12 plus 10. So your c value is 2, your period, okay, well it's 2 pi over 12, so our period is 12. Our amplitude is 6, and our vertical displacement is 10, and you can see that all from the graph. Okay, so I'm going to indicate on the graph where our c value is, which is right here, so c is equal to 2. And the other thing I'd like you to note is that on this graph we have 2 full cycles, one there and one here. Now there is an overlap on the graph, okay, and the overlap is between 0 and 2. Okay, here. And then if you go to the other side of the graph, okay, we have another maximum, and we should at 2 o'clock. Okay, so the other, this is the part that's overlapped. This will bring you to 12 o'clock a.m. Okay, so these parts of the graph overlap. Okay, so you can see that we have 2 full cycles on this one graph. All right. Okay, so we're going to do 374 and 377 and 380. Okay, so starting with 374, you've been asked to estimate the height of the water at 1:15 p.m. Now, all of these equations work on the 24-hour clock, so the first thing you have to do is to take your time of 1:15 p.m. and change it into the 24-hour clock time. So I guess that's military time. So 1:15 plus 12 gives you 13:15. But in order to plug that into the equation, we need the decimal form. Okay, which means we have to take the 15 and convert it into a decimal, so 15 over 60, which gives you 0.25. So our time then is 13.25 hours. Okay, and that's the number you're going to plug into your formula. And the formula we will use is the one that is on the graph. So H equals 6 cosine of 2 pi, and in place of t you're going to put 13.25, and then minus our c value, and all of that over our period, which is 12, and then plus 10. Okay, so we're going to put that into our calculator. So here is our graphing calculator. Okay, anyway, let's type that in. I can't make this smaller. Alright, so we want to go 6 cos 6 cos, and then 2 pi, bracket, and then we put in the 13.25, minus 2, close the bracket, divide it by 12, close our second set of brackets, and then plus 10. Okay, and we get a height of 15.54, and it's in meters. Okay, so H equals 15.54 meters. Okay, so that's just a matter of plugging your numbers in and getting your calculator out and calculating it on your calculator. Okay, so the next question, we are asked, at what times is the height of the water above 8 meters? Okay, so let's go to our graph, and where is 8 meters on our graph? Okay, well, on our graph, 8 meters is along here. And we want to know the times the height is above that value. Okay, so that means that we are looking at anything over 8 meters, so like this, like this, okay, and like that. Okay. So you see that there's 2 times during our period, double our period, 24 hours, that we have a high tide. So you know, part of the graph that's above the 8 meters. Okay, so how do we do this? All right, well, the first thing we're going to do, we're going to start with our equation. And what I want to do first is to reduce. Okay, reduce are 2 pi over 12. So when I rewrite the equation, I'm going to write that as pi over 12 because our calculations will be easier. Okay? So start by writing h equals cos. You're going to need a lot of room, so maybe you want to write on another sheet of paper. So it's 6 cos. And then bracket pi over 6 times t minus 2 plus 10. So we want to know the times that the height of the water is above 8 meters. So in place of h, you're going to put 8. Okay, and because we want to isolate, we talked about this in class the other day, we want to isolate the cos of everything inside the bracket. Okay, so what you want to do then is first move the 10 over, it becomes negative, and 8 minus 10 is negative 2. Okay. And then the next thing you want to do is divide by 6. So you're going to get negative 1/3 on the left-hand side of the equation, and cos of pi over 6 times t minus 12. So now it's isolated, okay? So now we're going to get the inverse cos of negative 1/3. And that's equal to pi over 6t minus t minus 12. Okay, so I'm going to, I know it's kind of awkward, but I'm going to move this over here now so we can finish off the calculation. Okay, so the cosine of, the inverse cos of negative 1/3 is 1.9106. And while I'm doing that, I'm also going to distribute my pi over 6. So that's going to give me pi over 6t, and then pi over 6 times negative 12. Well, 12 pi over 6. And I'm doing something wrong. Okay, that should be a 2. Okay. So pi over 6 times negative 2 is going to give me negative 2 pi over 6, right? And negative 2 pi over 6 will give me negative pi over 3. Okay, so now it's simply a matter of isolating the variable. So you want to move the negative pi over 3 to the other side. So you want to get 1.9106 minus plus pi over 3. And that gives you equal to pi over 6t. Okay, and then you get your calculator out. You're going to go 1.9106 plus pi over 3, and you're going to get 2.9578, which is pi over equal to pi over 6t. Now to isolate your t, you want to times both sides by 6 over pi. Okay, that's so that you can reduce your pi's and your 6's. That leaves you with t equals, and then times the 2.9576 by 6, and then divide by pi, and you get 5.65. Okay. Okay, so this 5.65 is in decimal form. Okay, and later we're going to convert that into hours and minutes. Okay, so let's go back to our graph and find the points that are of interest to us that will answer the question, at what times is the height of the water above 8 meters? Okay, so our 8-meter line is along here. Our first point, which is the 5.65, is right here. Okay, that's 5.65. The other point of interest will be across from it, below on the other side of the dip, so right here. So we want to find out what that is. And then we want to keep moving across the graph to the right, and we are interested in this point here, and keep moving right and interested in this point here. Okay? All right, so we want to find our second point. We're going to use the symmetry of the graph. So we can draw a line down through here, which is at 8, right? So what we want to do is we want to find out the distance from our point to this line that I just drew in. Okay, we want to find out how long that is in terms of time. So what we're going to do is we're going to go 8 minus 5.65, and what that gives us is 2.35. Okay, so this distance here is 2.35. On the other side, to our second point, we'll have the same distance, right? 2.35. So if I want to find the time on our second point, then I'm going to go 8 plus 2.35, and I get 10.35. Okay, now both of these times are AM times, so AM and AM. Okay, and when we go over to our third point, and we can count along from 3 p.m., 4 p.m., 5 p.m., we can see that this is also 5.65, except that it is p.m. And our fourth point then is at 10.35, which is also p.m. Okay, so now we can answer the question, at what times is the height of the water above 8 meters? So I'll do that at the bottom of the page. Okay, so we know that everything before 5.65 a.m., we know everything from 10.35 a.m. to 5.65 p.m. and then everything from 10.35 p.m. and later. Okay? So what we're going to do now is convert those into hours and minutes. Okay, now if we go back to what we did for number 374, when we converted from the hours and minutes into a decimal form, we had to divide the minutes by 60. But now we're going the opposite direction. We're going to go from decimal to hours and minutes. So we want to take the 0.65 of the 5.65, and we want to times it by 60, and that is going to give us 39. So 5.65 converts into 5 hours and 39 minutes, and that makes sense. You know, 0.65 is just over half of an hour, and so is 39 minutes. Okay, so this then becomes 5 hours and 39 minutes a.m. Okay, and then we will do the same thing for the 10.35. 0.35 times 60 gives us 21. Okay, so 10.35 is the same thing as 10 hours and 21 minutes. Okay, and so then our tide goes from 10:21 a.m. to 5:39 p.m. and then from 10:21 p.m. and later. Okay, so now we're going to answer our question for 380. How many hours per day is the water level greater than 8 meters? Okay, and this is where we're going to have to change our time of 10 hours and 21 minutes, or actually 10.35 hours into the 24-hour clock. Okay, so what we want to do then is we want to figure out, you know, how many hours is it between 10:35 a.m. and 5:65 p.m. Okay, so we need to take that 5:65 p.m. and convert that into the 24-hour clock. Okay, so 5.65 plus 12 gives us 17.65 hours. Okay, and now we want to take the difference between that and our 10:35. Okay, so 17.65 minus 10.35, and we get a difference of 7.3 hours. Okay, so when we go back up to the graph, that means that the time between here and here is 7.3 hours. Okay, now we have two of those, right? Because we have two times when the tide goes above 8 meters in the day. So we want to times that by 2. So we want to go 2 times 7.3, and we get 14.6 hours, and that's your answer. Okay. All right, so I just want to review with you converting from hours and minutes into decimal and from decimal into hours and minutes. Okay, so when we have something like 115, right, we got that from the first question we looked at, which was 374, and I want to change that into decimal form. Okay, then I want to do the 15 over the 60 to get 0.25, and so it becomes 1.25 hours. Okay, if we start with the decimal form, so for example the 5.65, and we want to convert that to hours and minutes, then you want to take the 0.65 and you want to times it by 60 to get the 39. And so it becomes 5 hours and 39 minutes. Okay, so that concludes our discussion on tides.